Hello friends, good morning and welcome to our channel Genius Structures. We have seen one introductory problem on moment distribution method wherein we solved a two-span continuous beam and one common joint was there, and we also saw how to distribute moment for these two spans. Today we have a little bit complicated problem, a different variety, and we shall try to solve this problem with moment distribution method. Okay, so let us see what is the given data. So we have this two span continuous beam. This is the first span is AB, second span is BC, third span is CD. So this is a statically indeterminate beam, and we shall see how to analyze this particular beam, draw its SFD and BMD using moment distribution method. So let us start. So in moment distribution method, our first step will be calculating fixed end moments. So let us do it. First step, fixed end moments. So let us see what these values will be one by one. So first span UDL is there. So MFAB equation is minus WL square by 12. So it is minus 10 into 4 square upon 12. So let us see. So it is minus 13.33 kilonewton meter. Okay. So MFBA will be naturally plus 13.33 kilonewton meter. Then second span is BC. So MFBC as well as MFCB, both fixed end moments will be m by 4. Why m by 4? We can see there is a centrally located clockwise couple, and because of this couple, fixed end moments on both the ends will be clockwise, not like one anti-clockwise and other is clockwise. Both will be clockwise if the couple is clockwise. Both will be minus if the couple is anti-clockwise. So m by 4 is the answer. So 35 divided by 4. So 8.75. Okay, 35 by 4 is 8.75 kilonewton meter on both the ends. Then MFCD, for CD span we have eccentric point load, so minus WAB square by L square. So let us calculate it. Minus 15 into 3 into 1 square upon 4 square. Okay. So 15 into 3 into 1 square upon 4 square is 16. So it is minus 2.81 kilonewton meter. Remaining moment MFDC, it will be plus WA square B upon L square. So let us calculate this. Plus 15 into 3 square into 1 upon 4 square. So it is 15 into 9 into 1 divided by 16. So answer is 8.44 kilonewton meter. Okay. So our second step will be finding out distribution factors. This step is relatively new. So let us see it. I will explain this in detail. Distribution factors. We will see these distribution factors in a tabular form. That will be easy for us. So let us draw that table. First column is joint, then member, then K value. K is stiffness of the member depending on boundary condition, then summation of K, and then distribution factor is for each member K by summation of K. This is how it is calculated. Now first of all list the members, the joints. How many common joints are there? There are two. One is joint B, another is C. Okay. From B, there are two members originating or meeting. One is BA, another is BC. Okay. Then we have to see K value for each member. How to see? Let us find out. K for BA member. So for joint BA is far end is fixed, so it is a case of propped cantilever. So for propped cantilever, K value is I by L. So I value for member BA is 1I. It is not given, so we will assume 1I. So I by 4. Then second member from joint B is BC. Joint C is again far end for joint B. Joint C is an intermediate joint, so intermediate joint is assumed as fixed. So again BC member is propped cantilever. So for propped cantilever, again I by L is the stiffness. So it is I by 4. So summation of these two values at joint B is 2 times I by 4. So we need not use Cal C for finding out distribution factor for each member. 2I by 4 divided by 1I by 4. So it is 1I by 4 divided by 2I by 4. So it is 0.5. So distribution factor for both the members is 0.5 each. Addition of these two values is 1. So this is the cross check that we have got. Now come to joint C. There are two members, CB and CD. Okay. So repeat the procedure for both the members. Just like joint B. So BC and CB will be one and same. It is not going to change. So you may write as it is for CB, just like BC. Okay. So it is same member. Now CD. For joint C, D is far end, D is end support. It is not intermediate support. So its boundary condition is it is simply supported end. So CD is not a propped cantilever case. It is simply supported end. So when far end is simply supported, I value is 3I by 4. So its I value is 3I by 4. Directly I have written 3 by 4 times I by L. I'm sorry. So this is 3I by 16. Okay, 3I by 16. So 1I by 4 plus 3I by 16. So I will write I by 4 as 4I upon 16. Okay, plus 3I by 16. It is equal to 7I upon 16. Okay, 7I upon 16. Now find out the distribution factors for both the members. So first member is CB. So for this K value is I by 4. So 1 by 4 divided by 7 by 16. So value is 0.57. So let us write this value of distribution factor 0.57. Next CD member. So it will be 3 by 16 divided by 7 by 16. So value 0.43. So again we have got a cross check. Addition of these two values is 1. Okay, addition of these two is 1. So we have got our distribution factors. Now we will distribute the unbalanced moments on common joints with the help of distribution factors. So we will now go to our third step, moment distribution. Okay, so let us see moment distribution table. I will just note down these values here. So minus 13.33 is here, then plus 13.33, then 8.75 on both the ends here, then minus 2.81, and last one is 8.44. Now let us rub this first. I will just first of all draw the table. So title for step 3 is moment distribution table. So here is our first end A. On joint B, we have two distribution factors. One factor is 0.5, another is also same. Then joint C. So on joint C, we have 0.57 for member CB, 0.43 for member CD. Okay, now we will start the distribution. First of all, we will enter the values, then we will start distribution. So first value is minus 13.33, I will enter here, then plus 13.33, then 8.75 both ends, minus 2.81 and 8.44. So this is support D, which is simply supported end, please remember. Now I will rub this. Now let us start the calculations. See, where are the common joints? Here, joint B first. So on joint B, what is our net value of moment? 13.33 and 8.75. Let us take algebraic addition of all these. So net value is 22.08 and its half value will be 11.04, but with opposite sign. Since the net value is plus, make it minus and distribute as per the factor. So minus 11.04. Now there is one small thing that we have to do. Please see. In last question, in our two span beam, end supports both were fixed ends. Here only one end support is fixed. The remaining end support is simply supported end, so their final moment has to be 0. So what do we have to do? We have to make that moment 0. So currently we have 8.44 final or the fixed end moment, so make it 0. So subtract 8.44 from this end and its half value will go to intermediate joint which is fixed joint. Intermediate joint is always fixed. Why? So this is fixed end, since this is intermediate joint, and this is simply supported end. So if you are applying moment here 8.44, its half value go to here. So how much we are applying? Minus 8.44 to make this 0. So if you are applying minus 8.44 here, its half value will go to far end which is fixed end. This is intermediate support, so this is assumed as fixed end. Please remember. So we will carry out this balance procedure. This is called balance. Okay, so minus 8.44 and its half value will go to here. How much is half of 8.44? It is minus 4.22. Okay, so this is balance. Now what we will do? We will mark a double line under these two values. Okay, so after marking this double line, we will recalculate the net values of moments coming on the joints. So there will not be change in fixed end moments up to this point. So minus 13.33 as it is, plus 13.33, 8.75, 8.75. What will be change here? Since this moment has come here, we will have to consider this also now below this distribution factor. So how much is this total? Let us see. 2.81 and 4.22, both are minus, so minus 7.03, minus 7.03, and how much will be this? 0. Okay, after doing this, now we will start with moment distribution. So this is only the change or the variety of problem. Now this problem is as good as same as that of the first case. So let us start. We have seen what is this value, 13.33 plus 8.75, that comes to be 22.08. It is plus value, make it minus and distribute as per the distribution factors. So 22.08 with minus sign into 0.5, so it will be 11.04. So minus 11.04 on both the ends. Fine. Both distribution factors are same, so distributed moments will be same. Go to next step. 8.75 and minus 7.03. How much is net value? 1.72 plus 1.72. Make it minus and minus 1.72. Now it will be multiplied by two factors separately. First 0.57. So value is minus 0.98. Then another factor 0.43. So minus 1.07 into 0.43. So value is minus 0.74. So first distribution cycle is over. Okay, so I am writing here now distribution. Now we have to take carryover. Now what is carryover? We have already seen this in previous session. So if the far end is fixed, to the far end we are taking half value of the moment, just like this. Okay, so half of minus 11.04, how much is that? Minus 5.52. We have to take along with the sign, please remember. Here also this is intermediate joint fixed. For this joint this is far end which is fixed, so its half value will be carried over here, minus 0.49. Here also same. This is also intermediate joint which is assumed as fixed. It is far end for this joint, so its half value will be taken here. So minus 5.52. Are we going to take half carryover of this here? No. Why? Because there is no fixity at the far end. It is simply supported end. So this is our carryover step. Okay, this is our carryover step. So after the distribution, we have again some lesser magnitudes of values which are unbalanced moments. They still need further distribution. So now initially we had these two values or these net values we distributed. Now we have these two values, unbalanced moments. Now we will distribute them further. So let us carry out. Minus 0.49 is unbalanced moment. Make it plus. So 0.49 into 0.5. So it is 0.25. We will round it off to plus 0.25 each value. Next is minus 5.52. Make it plus. So 5.52 into 0.57. So it is 3.15. 3.15. Here plus 5.52 into 0.43. So it is 2.37. 2.37. Our second distribution cycle or iteration, it is over. So I have taken second time distribution. Okay. Now I will again repeat this procedure of carryover. So repeat the same thing. Half of 0.25, how much? 0.125. Here same 0.125. Here half of 3.15, how much is that? 1.575. 1.575. Here no carryover. So now we have some reduced value of we have some reduced values which are unbalanced and we have to distribute them. So 1.575, make it minus. So its half value is 0.79. I am rounding it off. So minus 0.79 on both the ends. Here 0.125 with minus sign, please remember, into 0.57. So it is minus 0.07. And on the other end, minus 0.125 into 0.43. So it is minus 0.05. So my third distribution cycle is over. Now how many times to repeat this? Okay, how many times to repeat this? So there is one method to check it. What I will do is, I will just take I will stop distribution here. I will not take carryover now, and I will take the algebraic addition of all the moments below the double line. Okay, below the double line, and I will see whether is there any necessity to take one more distribution cycle. So I will just do it. I'll do for first intermediate joints. Okay, so I'll take all values below the double line. Please remember 13.33 with plus sign, minus 11.04, plus 0.25, minus 0.79. So that comes to be 1.75. 1.75. Now take these values. It should come minus 1.75. Okay, So first below the double line is 8.75 minus 11.04 minus 0.49 plus 0.25 plus 1.575 minus 0.79. So it comes to be minus 1.745. So I can round it off to minus 1.75. Okay, so this is plus 1.75. This is minus 1.75. Okay, let us go to joint C and calculate again the values again below the double line. So 8.75 minus 0.98 minus 5.52 plus 3.15 plus 0.125 minus 0.07. So it is 5.55 plus 5.46. Next, this side. So minus 7.03 minus 0.74 plus 2.37 minus 0.05. I am getting minus 5.46. Okay. Yes. So I have got these values. So initially when we started, there were unequal moments on both the ends or the opposite ends of joint B. Here we have equal and opposite values which are balancing each other. So net moment here is 0. So if there is any difference here, say 1.75 and 1.65 minus 1.65, if this is the case, you carry out one more distribution cycle and then stop. Okay, if there is no necessity, like in this case, you can stop distributing moments here itself. So my one more value is remaining. It is here. I will calculate quickly. Minus 13.33 minus 5.52 plus 0.125. So my answer is minus 18.73. I will just note down here. Minus 18.73. Here it has to be 0 because we have initially itself made it 0 because end support is simply supported end. Now we can go for drawing SFD BMD. Again, somewhat lengthy part, but there is no alternative. So let us do it quickly. I will just note down these values here with red color. So minus 18.73 here, anti-clockwise. Then on this end, this is clockwise. Another is anti-clockwise. Value is 1.75. Okay, on joint C 5.46. So these are my final moments on the joints. Now we will find out first of all these reactions one by one, and then we will draw SFD, then we will locate points of zero shear force, and then we will go for BMD. So let us do it. Now I will rub this. My step number 4. Here you can write final moments. For this row you can write here final moments. Okay. So from this table we have got final moments on end supports and intermediate supports. Now we will find reactions. So step number 4, reactions. So there are three spans. So take free body diagrams of all the spans one by one quickly and then find reactions. So first span AB. Here is UDL. So this is 10 kilonewton per meter. This final moment is 18.73 anti-clockwise. Here clockwise moment of 1.75. and we have to find these two reactions RA and RB1. So take summation of moment about joint A, it is equal to 0. Write the equation minus RB1 into 4 plus 1.75 plus 10 into 4 square by 2 minus 18.73, it is equal to 0. So calculate RB1 quickly. So 1.75 plus 10 into 4 square by 2 minus 18.73 divided by 4. So answer is 15.76. RB1 is 15.76 kilonewton. For the same free body diagram, apply summation of Fy is equal to 0. So Ra plus 15.76, it is equal to 40. So what will be Ra? 40 minus 15.76. So answer is 24.24 kilonewton. One free body diagram is over. Go to second. So here we have this clockwise couple of 35 kilonewton meter. This is 1.75. Anti-clockwise, this is 5.46 clockwise. So we will say this is RB2 because there are two reactions on joint B. This we will call RC1. So summation of moment about, this is 2 meter each, about joint B. So minus RC1 into 4 plus 5.46 plus 35 minus 1.75. So this is equal to 0. So how much is RC1? Let us see. So it is 5.46 plus 35 minus 1.75 totally divided by 4. So it is 9.68 kilonewton. Then apply same summation Fy condition. So here you will get RB2 plus RC1 equal to 0 because there is no external load, it is coupled. So RB2 is minus 9.68 kilonewton. Okay, so what will be net RB? RB1 plus RB2. What is RB1? 15.76. What is RB2? Minus 9.68. So write this value 15.76 minus 9.68. So answer is 6.08 kilonewton. Similarly, find now RC2, then net RC and RD. So go to third free body diagram. This is RD, 15 kilonewton load, then anti-clockwise 5.46 moment. This is 3 meter, this is 1 meter, this will be RC2. So find out summation of moment about joint C. So minus RD into 4 plus 15 into 3 minus 5.46, it is equal to 0. Okay, so calculate 15 into 3, 45 minus 5.46 totally divided by 4. So it is 9.89. RD is equal to 9.89 kilonewton. Then summation Fy is equal to 0. So RC2 plus 9.89, it is equal to 15. So what will be RC2? 15 minus 9.89. So it is 5.11 kilonewton. 5.11 kilonewton. So what will be net RC1 plus RC2? So what is RC1? 9.68, RC2 5.11. How much? Let us add this. So it is 14.79 kilonewton. 14.79 kilonewton. Note all the four reactions here. Ra 24.24, net Rb 6.08, net Rc 14.79 kilonewton, and net RD RD is 9.89 kilonewton. Now we will draw shear force diagram. Okay. So again I will rub all this because it is not required. So I will just take the projections first for the reference. Then we will locate points of zero shear force. Their bending moments will be maximum, and we will find out what are the bending moment values there. First of all, we will plot SFT. Okay, so 24.24 is here, shear force value. From this subtract 10 into 4, so 24.24 minus 40 is minus 15.76, minus 15.76. In this you add 6.08, so plus 6.08, answer will be minus 9.68. so somewhere here 9.68, sorry, yes, it is correct. Then it will be continued up to this end, and in this value of minus 9.68 we will add 14.79, so 14.79 plus, so 5.11, 5.11 kilonewton. It will be same up to 15 kilonewton load. So 5.11 minus 15, it comes to be minus 9.89, minus 9.89. So we are getting the cross check here. Okay, so this is 5.11, so this is plus, minus, plus, minus. So we have this one additional point where there is zero shear force, and its location we don't know. Okay, its location we don't know. Here is zero shear force point, but it is, we know where it is, 1 meter from support D. So first of all we will calculate this location, find out this location first. So x, and here 4 minus x. So using similarity of triangles we will find this. So 15.76x, that is equal to 24.24 into 4 minus 24.24x. So simplify this equation, we will get x value. So 24.24 into 4 divided by 15.76 plus 24.24. So answer is 2.42 meters. X is 2.42 meters. So take a section at this distance of 2.42 meter. Consider this part of the free body diagram. Write the equation of bending moment. So bending moment at x is equal to 2.42 meter. Let us see what the equation is. So 24.24 into 2.42 minus 18.73 minus 10 into 2.42 square by 2. So let us see the equation, the value. Answer is 10.65 kilonewton meter. Here we shall say this is E, we will assume this is F, we will assume. So bending moment at F is 9.89 into 1. That's it. So answer is 9.89 kilonewton meter. Where is one more location? Here. What will be value here? Take again the section here and consider this free body diagram. So we will assume this as G. So bending moment at G is 9.89 into, how much is this distance? 1, 3, 4. 4 plus 2, 6. Then minus 15 into 5. Then plus 14.79 into 2. Yes. And we will consider this part also, which is minus 35. So let us see now. 9.89 into 6 minus 15 into 5 plus 14.79 into 2 minus 35. So it is minus 21.08. kilonewton meter. So minus 21.08 kilonewton meter. So let us plot the values now one by one. So I think there will be some correction here, whether to consider this minus 35 or not, we shall see. First of all, plot the values. Bending moment here is 18.73. Then this is 1.75. This value here 10.65. Then here, yes, if I consider this left hand side, I will get the value 24.24 into 6 minus 18.73 minus 10 into 4 into 4 plus 6.08 into 2, so minus 21.13 if it is on left hand side of G, so minus 21.13. okay. And if I just go on right hand side, so minus 21.13 plus 35, I'll get 13.87. So it is here 13.87. So this minus 35 need not be considered. Okay. This is 21.13. Here value is 5.46. Here value is 9.89. Is it plus? Yes, it is plus 9.89. Now let us join all the ordinates. A to B is UDL, so variation is parabolic. Rest all the variation will be linear. Everything will be in straight line. This is minus, this is plus, minus, plus, minus, plus. So this is our BMD on tension side, and this diagram is SFD for the continuous beam. So friends, this is how the analysis of this particular 3-span continuous beam is. It is a little bit lengthy, yes, and to start with it is somewhat complicated. One care we have to take that we have to release the moment on end support. Why? Because end support is simply supported end. If the end support is fixed end, we need not carry out the balance step. Okay, so friends, this is my analysis on this particular beam by moment distribution method. If you have not understood, you can ask your questions in the comment section. If you are new to this channel, do like and subscribe the channel and also share it. And thank you very much.